Hi, I'm Leah from the MARIS program, and I'm going to present to you the Immersion Project Effects of Global Change on Mediterranean coralligenous assemblages that I've been in charge of. It takes place in the Laboratoire Océanographique de Villefranche, the LOV, and the lab is situated in the heart of the Bay of Villefranche-sur-Mer. And as you can see, it's a quite unique place for marine research. The team SHOCK, Chemistry, Ocean and Climate, in which I work, aims to study the impact of the climate and other external factors on biogeochemical cycles and marine organisms. My project is done under the supervision of Steve Como, a research scientist of the LOV. But let's talk about the project itself. As you may know, global change is threatening all ecosystems in the world, and its effects are already visible in the Mediterranean Sea, a hotspot of biodiversity. The charismatic Mediterranean coralligenous ecosystem shelters close to 20% of the Mediterranean species. It is highly threatened by increasing temperature and decreasing pH. The crustose coralline algae, which is the engineer of these ecosystems, are studied during this immersion project. The ultimate goal and the most innovative aspect of the project is to evaluate the effects of the changing environmental condition on several generations of coralline algae in order to study their capacity of acclimation and adaptation. We focus on long-term investigation of the effect of elevated temperature. We work on two species, Mesophyllum alternans and Lithophyllum cabiocae. They were directly collected from the bay. We began the year running tests on Mesophyllum that were maintained in 4 different treatments and replicates, representing a range of temperatures that these species are likely to experiment in the near future, from 22 to 28 degrees. For every treatment, we placed adults in separate tanks and we waited for the algae to reproduce. When we had enough recruits in each tank, we removed the adults and obtained our third generation. Then, to evaluate the health, I monitored several physiological parameters such as photosynthesis and respiration, the color of the tissues, and their growth. The effect of temperature on these parameters were statistically investigated, and we found that over one generation only, the metabolism of Mesophyllum alternans was increasing with temperature. However, we also showed that this species was not optimal for prolonged incubation in aquaria, as they were too sensitive and did not reproduce fast enough to obtain several generations in 1 year. We have therefore decided to use another species and began a new experiment with it. It's Lithophyllum, which is known to be easier to grow in captivity. Now I am looking forward to seeing the response of the future generation and perhaps even adding a change in pH. So the next intern will have to keep the experiment on track. That implies what I've done this year by monitoring the experimental parameters, learning of the different methods needed, and the assessment of our little recruits' health. But what is pretty great about the LOV is that the intern will have to propose new ideas to improve the experiment, so that he will leave his own mark and he will also be able to meet nice and unexpected organisms.